I think last year she had a publication in ICC workshop.
Yeah. Okay. Nice.
And
I saw your publications are in very, very good journals, and many your citations are alhamdulillah very nice. So because your most of the work is published in very, very esteemed journals in IEEE.
Thank you. Thank you.
It's what is the time? No, it is. So we can start. So let me briefly introduce Dr. Mubashir, and then we can award to Dr. Mubashir. So Dr. Mubashir has received his bachelor's in computer system engineering from Mehran University of Engineering and Technology in 2004. Then he did his master's degree in 2008 from University of Paris. He did his PhD in 2011 from University of Paris and Marie Curie. He is currently working as a lecturer in Department of Computer Science at MTU, Ireland. He has authored and edited around 8 books. And one of those books is basically on the blockchain, which he published recently. He was ranked as #1 in all engineering disciplines in 2017 from Pakistan Council of Science and Technology, Ministry of Science and Technology, Pakistan. He has an accumulative impact factor of around 600 with an H index of 40, I-10 index of 85, and citation more than 7,000. He has several best paper awards. He is also serving as editorial board member for a number of reputed journals for IEEE as well as Nature publishers. He has more than 100 publications in highly impact factor journal, transaction, and magazines. He is among the top 100 scientists in terms of citation in the field of computer science, as per the recent report published by Stanford. So thank you so much, Dr. Mubashir, for being with us. So we really want to listen to you, and I hope that this presentation will be very, very fruitful as well as informative for the audience. Thank you so much for being with us. Over to you, Dr. Mubashir.
Thank you so much. Assalamu alaikum to everyone, and it's my pleasure to talk with you. That I'm talking with you in IEEE Dhofar University student branch. So basically, the theme of my topic is blockchain systems for communication networks, and I will be highlighting few challenges and emerging trends where one can start conducting their research. And I will also talk about some of my works as well. So before we further proceed, let me give you some context about blockchain technology. We may have heard about different cryptocurrencies like Bitcoin, Ethereum, Litecoin. So these cryptocurrencies, they are in the market, and they have a huge market capital. And if we look back, the prices of these cryptocurrencies, and these prices are back in May 2021, and the Bitcoin was more than $50,000 and the Ethereum was also the price of Ethereum was also more than $2,000. So these prices are showing the impact these cryptocurrencies are creating, and the underlying technology. Basically, the underlying technology behind these cryptocurrencies are basically the blockchain technology, or in simple words, we can say that blockchain is a distributed ledger system. Now, there are numerous cryptocurrencies available in the market, more than 100, and the governments and banks are making their policies to adopt these cryptocurrencies or to regularize. Although it may take some time, maybe because of the conspiracies and other technical issues that these cryptocurrencies have, but they are there, and a lot of people have huge investment on these cryptocurrencies. Now, blockchain is basically a distributed ledger that is structured into a linked list of blocks. So I'm focusing here on a blockchain. There are other types of distributed ledgers as well, like DAG, DAG, and others as well. But the focus is on blockchain. So blockchain is basically distributed across many machines, and blockchain system is secured through cryptographic hashes. And there are the system of blockchain is very strong, that makes it unique. So that's why they have been used in the cryptocurrencies. Now, I mentioned that a blockchain is basically a distributed ledger technology. So the first question arises in our mind is, what is a ledger? So ledger is basically a principal book or computer file where we record and measure, store data and transactions. There can be several types of ledgers: sales ledger, purchase ledger, general ledger, which stores different information, including accounts receivable, amount of the money spent for purchasing, and liabilities, income, expenses, and capitals. So these ledgers basically, if we look back before the computer era, these ledgers were maintained in manual registers. People were recording these records on copies and registers. But with the advent of computers, these ledgers move to computer, and we use a different type of spreadsheets, word processing softwares, and databases to store that data. So as you can see, previously those records were managed manually. Then with the arrival of computers, they moved to computers, and people were using spreadsheets and word processing softwares. And then when there was further advancement, then we have databases, dedicated databases available in the market, where we have multiple computers that are connected to the central computer, and the central computer has the capability to manage all those records distributed on different computers. Now, until here, the things are going well. Now, with the advent of blockchain technology, what is happening is that we are removing this central entity, and now the computers, the records will be saved on computers, on each and every computer, and there will not be any single entity or central entity which will be controlling all these transactions and record. So this is basically the idea behind blockchain. More precisely, if you look at the architecture of blockchain, you will see it consists of blocks, and the blocks are linked together through linked list data structure. Now, the first block of any blockchain system will be called as the genesis block. So the block will have two components, block header and block body. The block header will contain information about block number, the previous hash value, the hash value, and the block body will have different transactions. These transactions can contain any type of information. It can be the amount of amount of money being transferred, cryptocurrency being transferred, or there can be other information that we can store in the header of the in the body of the block. Now, as you can see, these blocks have the block number, and then the next block will have the hash value of the previous block. So this will ensure that the integrity of the data within the block. So hash function basically ensures the integrity of the file. So let's say if we have a file which contains hello world, some information, and if we generate the hash value of that file, we will get a unique hash value from that file. And if we just include any other sentence or any other word or even a full stop in that file, the next generated hash value will be completely different. So if you want to check the integrity of the file, that the file has not been fabricated, we can check the hash value of that file. And if it is compared and is the same as the original hash value generated, then it means that there is no fabrication or alteration in the data of the file. So this is how the blockchain is linked together. Now, if we compare blockchain with database systems, there are numerous differences and numerous similarities. So basically, blockchain can replace, has the capability to replace database systems. Now, it is not always the case, means blockchain is not always suitable for each and every case where we have been using database system. So there need to be some analysis based upon which we can decide whether blockchain is a suitable solution or not. Now, coming back to the differences and common features of a blockchain and database system. So both the database systems and distributed ledger technology or blockchain contains the common records. However, when we talk about database systems, although there are distributed and decentralized database systems, but in principle, blockchain does not have a central entity. I'm talking about public blockchain here. And the database system, we can consider that there can be a central entity. In blockchain, we have consensus, and this consensus is managed through mining nodes. Mining nodes are the specialized node that solve the puzzle and add a block in a blockchain network. However, in database systems, that consensus can be achieved through a central entity. Now, what does it mean by consensus? So basically, when an operator or when a user enter a record in a database system, that record need to be validated and included in the database system. So it's a central entity in a database system that allows user to enter that record. And if the central entity discards that entry, that record will not be the part of the database system. So similarly, in blockchain system, if we want to add a block or if we want to make a transaction, that transaction or that block need to be validated and consensus should be achieved. Now, since in a public blockchain, there is not a single central entity, so there are mining procedures. There is consensus algorithm running underlying. So based upon that, they make consensus and a block is added to the blockchain. Now, in terms of duplication of data, typically in a database system, few nodes or central entity keeps the whole information or data or ledger. However, in blockchain, each and every node keep the data, the whole ledger. So here comes the problem, because if you talk about future communication networks, let's say Internet of Things. So Internet of Things devices where we have less memory, it is difficult for the IoT devices to keep the complete ledger. So there are some solutions and there are some issues as well for lightweight devices. Now, in terms of global view, both have the global view and both can be distributed. If we go into further depth and compare with the features, so in a database system, we don't have hashing, and hashing is that unique feature that makes different blockchain from the database system. And hashing is applied at different stages and at different levels, and it makes the blockchain system very secure. Then we also have the public-private key, which is generally not applied in the database system. However, in blockchain, it is an essential requirement. In blockchain, we have a sequence of records, while that may not be possible, or that may not be the case in the database system. Similarly, in terms of consensus, again, the consensus is achieved through a central entity. However, in blockchain system, this consensus is achieved through the consensus algorithm through the mining nodes. One of the unique feature of a blockchain system is immutability, means the blockchain records are immutable. That is, no previous entry or transaction recorded in the ledger can be modified. And this feature is not present as such in the database system. So once we have an entry, now that entry cannot be removed from the blockchain system. However, in database system, you can have multiple commands, you can have the control to completely remove that record from the database system. In terms of dissemination of the ledger, in traditional database systems, once any update is made in the ledger, the state of the ledger is not required to disseminate among all the participating nodes. However, when we talk about blockchain system, all this update need to be disseminated to all the participating nodes of the blockchain system. There are some other vital characteristics of blockchain system. For example, decentralization means when we talk about public blockchain, there will be no central entity or intermediary to control and validate the transactions. It is transparent. Anyone can track the transactions and follow the complete ledger. Even if you look at the public ledgers like Ethereum or Bitcoin, you can check how transactions has been carried out and what was the amount of the transaction and the complete trail of the transactions. That is why blockchain has got some attention for money laundering and other areas, and it is very famous to identify such sort of cases. Similarly, we have the immutability capability, non-repudiation, and auditability. So non-repudiation is basically if someone has made a transaction, then they cannot disown it. That is called as non-repudiation, which is another vital characteristic of blockchain system. Now, if we look at the blockchain system and try to categorize blockchain, we can categorize into public blockchain, private blockchain, and consortium blockchain. Now, the public blockchain is completely decentralized, and it is freely available. It is publicly available over the internet, and anyone can go and see and monitor the transactions. And on the other hand, on the other extreme, we have the private blockchain, which is completely centralized, and public entities, public users cannot participate without the permission of the blockchain owner. There are some use cases where we can use private blockchains. For example, if there is a bank which has some internal organization or internal operation for a certain application, they can create a blockchain and nobody outside from the bank can access that private blockchain. Now, in between, we have the consortium blockchain, which has both the feature, means it is partially centralized. So let's say when we talk about automobile sector, different vehicle manufacturing companies. So if they make a consortium and then they manage a blockchain system, that type of blockchain system can be considered as consortium, because there will be a consortium of vehicle manufacturing companies who will be managing that blockchain system. Now, similar to when we compare the blockchain system with the network, so in network we have different types of layers. We organize the network in different layers so that we can understand the working of each and every component of the system. So similarly, we can also think about blockchain in terms of layers. Now, the bottom layer is hardware layer, where we have the underlying hardware, and that includes CPU, GPU, and other hardware. And remember that we can execute our blockchain system not only on our laptops or computers, but on mobile phone, and there are other dedicated devices as well, where we can operate our blockchain system, or we can we can install wallets and other distributed applications as well. Now on top, above the hardware layer, we have the data organization and topology layer, where we conduct different operations like hashing, data ordering. It is dependent upon the type of the distributed ledger that we are using. If we are using the linear linked list, then it will become blockchain. If we use DAG, then it's a different type of distributed ledger. Ledger storage, cryptographic algorithms, sidechain, sharding, off-chain, all these issues are considered under the data organization layer. Above that, we have the network and operating system layer, where we look for the communication mechanism, peer discovery, routing, peer-to-peer network, and all such issues. Above that, we have consensus layer, where we have different types of consensus algorithm working, like proof of work, proof of stack, PBFT, Ripple, and there are numerous other consensus algorithms. So consensus algorithm try to reach consensus among the blockchain participating nodes so that a block can be added and validated. Now, depending upon the type of the blockchain, as I mentioned, there are three types of blockchain systems. So the selection of consensus algorithm will vary. So we cannot apply a consensus algorithm dedicated for private blockchain, or even in private blockchain, there may not be a need of a consensus algorithm. But for consortium blockchain, we cannot take a consensus algorithm designed for a consortium blockchain and apply to the public blockchain. And the same cannot be happen vice versa. Now, above that, we have the virtualization and smart contract layer, where we can have compilers, DVM, distributed virtual machines, smart contracts, etc. And on the top, we have the application layer, where we can use this blockchain system for different applications in different sectors, including cryptocurrencies, communication networks, record management, and other things. So this was just a very quick introduction about the blockchain systems. There were a lot of other details which I skipped because I need to move towards the main theme of our topic, how we can use blockchain system in communication networks. So if we look at the communication networks, broadly, we can classify into two types, wired networks and wireless networks. In wired networks, we need a medium of fiber optic or Ethernet cable. While in wireless networks, definitely we need the medium, but that medium is wireless radio spectrum that help us to communicate. So we will be focusing more on the wireless network aspect. So there are numerous wireless networks we can see around us, including cellular networks, satellite networks, Wi-Fi, mobile communication networks. And now these wireless communication networks, basically they operate on certain frequency band, and we call this frequency band as wireless radio spectrum. And this wireless radio spectrum is basically a natural resource. Like we have petrol, gas, and other minerals, the wireless radio spectrum is also a natural resource. So as you can see, we have different wireless standards, different wireless applications, including GSM, Bluetooth, Wi-Fi, AM, radio communication, TV broadcasting, mobile communication. So all those are using a different portion of the frequency band. And some of these applications can be applied indoor, and some of those can be applied outdoor, and some of those applications work for both environment, like mobile phone. We can operate it out within the home and outside the home. So there is no issue in that. So basically this wireless radio spectrum can be divided into two major portions: licensed band and unlicensed band. Licensed band is the one which can be taken from the government by the cellular companies, and cellular companies, mobile operating companies, then build their network and operate their network on the licensed band. While unlicensed band is basically free to use, we have this ISM band in it, and we normally operate different free communication network on these unlicensed band, including cordless phones, Bluetooth devices, NFC devices, Wi-Fi, garage door openers, etc. Now, this wireless radio spectrum is very costly. If you look at the auction that was made for 5G mobile spectrum in Germany, it raised 6.55 billion euros for a small chunk of the spectrum block. So that is very costly. And if you ask the telecom operators, they will tell you that how much it's precious, and how the competitors are going to trying to use that wireless radio spectrum. So this wireless radio spectrum is assigned in a fixed term policy. So as you can see over here, we have this United States frequency allocation map, and on top we are starting from kilohertz, and then we're going to megahertz and gigahertz spectrum band. And the color blocks within this spectrum band, spectrum map shows different usage and different allocation of the spectrum for different applications. For example, if we talk about the AM radio broadcasting, this portion of the spectrum is allocated for AM radio. And if we talk about TV broadcasting, this portion of the spectrum is assigned for television broadcasting. Similarly, at higher frequency band, you can see there's a lot of congestion and there is a lot of occupancy. And this is basically the fixed spectrum assignment policy. Now, why we have very less congestion on lower frequency band and why we have higher congestion at higher frequency band? The reason is basically because of the nature of the wireless radio spectrum. When we are at lower frequency band, we have less bandwidth, and when we move towards higher frequency band, we receive higher bandwidth. So that's why when we want to operate 3G, 4G, or 5G, or any other higher bandwidth requirement applications, we move towards higher frequency band. But on the other hand, there's an issue. Which issue is that when we go towards higher frequency bands, the coverage area gets smaller, and we need to look at the trade-off that the nature impose on this wireless radio spectrum. So we cannot build mobile communication networks on terahertz band, although terahertz band provide us a lot of bandwidth. But because of the coverage area, because of the traveling of the signals, we cannot deploy BTS base stations each after a few meters or few hundred meters. So that trade-off is still a need to explore. And although there are a lot of techniques that has been used by researchers and scientists around the globe to optimize the usage of the spectrum, for example, multiple access through different other techniques, reallocation of the frequency band, the cellular concept, and modulation techniques. So all these are there to optimize the usage of the spectrum, but still science is unable to tackle this trade-off, because this trade-off is imposed by nature. So we have to design our communication networks considering that constraint. Now, this is the wireless radio spectrum map of Ofcom UK, and again you can see different frequency bands are assigned for different purposes. And basically, when we talk about the fixed spectrum assignment policy, it results in the less utilization of the wireless radio spectrum. So as you can see, if we observe the spectrum, so we can see that spectrum is not completely utilized over different frequency bands at different geographical locations and different time. So researchers well back a decade ago, they identified this problem and they came up with a solution that why not we fill these gaps, and they came up with a dynamic spectrum assignment policy. And this dynamic spectrum policy can be achieved through a technology which is known as cognitive radio network. So cognitive radio is basically uh, a radio, a mobile phone, a device that can be programmed and configured dynamically, and it can change its transmission and reception parameter. There are two types of nodes within the cognitive radio network: primary users and the secondary users. Primary users are the licensed users, and the secondary users will be the unlicensed users. So what will be the main functionality of a cognitive radio device is that they will try to sense the wireless radio spectrum, and if they found any non-utilized spectrum or white space or free spectrum, they will start making communication over that network. However, they need to change the spectrum frequency band and move to another spectrum band when they find any primary user activity. Now, cognitive radio nodes can opportunistically exploit the license band, and there are four major functions that a cognitive radio typically perform. The first one is spectrum sensing. In this phase, the cognitive radio device try to detect the unused spectrum and the presence of the licensed user. For example, if we have a cognitive radio device or SDR, software defined radio, we can sense the radio spectrum of let's say 1800 megahertz or 900 megahertz and see if someone is using a mobile communication network or not. And if we find there is no usage on that particular spectrum band or frequency, we can then start communicating. But remember that since it is a licensed user, so in different countries, it is still not possible because of the regulator. So we need to, so there are different business models and there are different, steps in the progress for realizing this technology. The other function is basically the spectrum management, where once the cognitive radio device identifies the unused spectrum, they then select the best channel. The best channel can be based upon different criteria and parameter. It can be the duration of the time for which the channel is available. It can be on the quality of the channel, and it can be on other parameters as well. Then we have the spectrum sharing phase, where the cognitive radio can coordinate the access of this channel to other users so that all the other users can also benefit for this. And then if finally we have the spectrum mobility, where if the cognitive radio device believe that a primary user is coming, then they vacate the channel and try to communicate on the other channel. Now, in terms of architecture, so here you can see on the left-hand side, we have the primary network. In the primary network, we have primary radio node, PR nodes, and the primary base station. So these are the license users and the license network. Now, on the right-hand side, we have two possibilities of cognitive radio network with infrastructure and without infrastructure. With infrastructure, we can have a cognitive base station where the cognitive radio devices will be communicating and establishing their network and performing different tasks of spectrum sensing, spectrum sharing, etc. So the cognitive base station will be communicating and helping out the cognitive radio devices. Now, without infrastructure setting, we will not be having any base station, and the cognitive radio devices themselves have to coordinate and collaborate and identify and perform all the functions associated with the cognitive radio cycle. Now, I previously mentioned that one of the goal of cognitive radio devices is to identify the white spaces or the free spectrum portions. Now, this spectrum portion, as you can see, these are the white spaces or free spectrum portions. It can depend upon the time, day, geographical location, and other aspects. So if we talk about from the perspective of the primary user, there can be a long-term activity. For example, sometimes people make long calls on certain periods of the time. Let's say free call packages. So it will produce in the form of long on and long off periods. So here you can see if a cognitive radio device try to use this portion of the spectrum, long off period, they can easily use that. In high PR activity regime, we have long on and short off period, and such type of setting can be seen in rush hours or urban areas. So here, when the cognitive radio user will try to exploit this, they will have not that much opportunity to make their communication. In the low PR activity regime, we have very less primary user activity, and such activity can be found in remote areas or less peak hours. And here we can, the cognitive radio devices can communicate easily. And then finally, we have the intermittent PR activity, where we have short on and short off period activity, and such type of activity can be found in bus stations and railway stations. And the goal of the goal of the CR node is to identify such activities and then start their communication. Now, this cognitive radio technology is well established, and since decade there has been a lot of work. Even if you look at IEEE itself, in IEEE we have standard developed like IEEE 802.22, which is basically TV white space. Here we try to use and build cognitive radio network and try to use the underutilized spectrum for the TV white spaces. And we also have Wi-Fi standard IEEE 802.11 AF, in which we can use wireless LAN operations in TV white space. There are other applications of cognitive radio as well. For example, we can have cognitive radio sensor networks. We can use cognitive radio in tactical networks, and we can also use in cellular communication networks as well. So just to give you an example, let's say we have natural disasters, and we don't have control on these natural disasters. So these natural disasters can be in different forms, from volcano eruption to earthquakes to storms or heavy rains. They result in basically the partial destruction or complete destruction of the communication infrastructure. So when such disaster happen into a particular location, then the communication network gets destroyed, and we need urgent need to facilitate the victims and perform rehabilitation works. So for that, basically we need a disaster response network, and in that perspective, cognitive radio network can play a vital role to provide urgent communication to help the rescue team members and NGOs to perform organized help. Now, how basically this blockchain technology can be applied to communication networks? So just to give you a broad spectrum first. So in this blockchain technology can be used in different purpose. Think about the use of database system, and wherever you use database, you can use blockchain technology. Not in all cases, definitely, but you need to perform some detailed analysis, feasibility analysis, and there are some questions which one need to answer, and then they can think about using blockchain and replacing database system. So for example, we can use blockchain for for roaming management. Sometimes we are in one part of the continent, and we move to another part or to a different country. So there's a roaming procedure. Now this roaming is basically quite complex, and when we move to one country to another, there are different tariffs, and there are procedures. So those procedures can also be solved through blockchain system. There are numerous works available on roaming, but on blockchain based roaming, there are few works. For example, from the researchers from Canada, they have proposed to use blockchain for the management of roaming and tariff and all such things. Similarly, we can use blockchain in multimedia networks, where we can check the video integrity and even track fake video. We can also audit the content of the video through blockchain. We can use smart contracts for video content, and we can even perform content sharing through peer-to-peer procedure of the blockchain system. Moreover, in the context of green IoT, we can use blockchain for secure wireless power transfer. And in Wi-Fi network, we can use blockchain for congestion avoidance and anonymous access control. So these are few of the applications that I am mentioning over here in general. So I have mentioned the details of these in my book, and there are a lot of good works references available as well, where we can explore the precise technical problem that these researchers have addressed while they were thinking to implement blockchain system for these particular types of communication network. So let me give you some examples, some more precise examples. The question is how we can use blockchain for cognitive radio network, or more precisely, how we can use blockchain for the management of the wireless radio spectrum. So basically, you can see blockchain can help us to establish trust among different organizations. So it can also be used for the management of the spectrum, and the spectrum regulatory bodies can use blockchain, and the benefit, it will bring a lot of benefits to the telecom sector. Now, if you look at the wireless spectrum cycle, you have the spectrum regulator, and that spectrum regulator basically auctions the wireless radio spectrum, and then the different mobile operators, telecom mobile operators, they use the wireless radio spectrum and then build their network. So once this spectrum regulator assigns the unusable frequency chunks, then it can be assigned to the BTS, and then it can be assigned to the primary users, and then it can be used by the secondary users or cognitive radio users by trading it. So this whole spectrum cycle can be achieved through blockchain system in an easier way, in a manageable way. And this spectrum trading can be very useful if we use smart contracts. Now, smart contracts is an integral part of the blockchain system. This will bring new business models for spectrum trading. So now spectrum trading is there, but for long periods of time, or for huge portion of the spectrum. But when we incorporate blockchain to this spectrum trading paradigm, we will have new opportunities and new possibilities of the businesses, which I will explain in the next slide. It is also possible that we can use blockchain system for future trading as well, and it can significantly reduce the business processing time and make the system more autonomous, and the administrative issues will be much more better when we move towards blockchain. Now, as you can see, the traditional spectrum buying and selling is for years, months, and weeks. But if we think about using blockchain through smart contracts, we can perform the trading of the spectrum even for days, minutes, and seconds. And this is one of the area where I'm currently focusing and trying to see what benefits we can bring to this whole paradigm if we apply blockchain and try to go for spectrum trading for days, minutes, or even seconds. And this basically concept will enhance the spectrum utilization as well, and it can improve the revenue generation. But still, it's ongoing work, and I still need to investigate with my students that how much benefit we may get in terms of spectrum utilization, and how much revenue we may get, improvement in the revenue. There is another application where we can use the blockchain system, which is a smart grid communication network. So a smart grid is basically an advanced form of the communication network. As you can see, the traditional grid, electrical grid, has a unidirectional flow of the electricity. However, in a smart grid, we have the bidirectional power and information flow. So we have the power flow, as well as we have the well integrated communication network, and we also have different sensors. We also have information and communication technologies tightly coupled in a smart grid system, and we also have the renewable energy resources within the smart grid. So now this smart grid becomes smart grid when we have a very strong and powerful communication network. So this communication network basically help us to perform different functions, from load monitoring to integration of renewable energy resources. Now, blockchain can also be used in the context of a smart grid. For example, uh, how we can create different energy among different participants of the smart grid. And we can also have this net metering concept where the users of the utility inject back the energy to the grid, so they can help energy traders to generate some revenue. We can also have the virtual power plant concept, which facilitates energy trading. So among all these aspects, one can use blockchain as an application, and it can bring a lot of benefits to these systems. So this is all about my presentation. So just to give you an highlight, I have written a textbook on blockchain systems and communication networks, which was published by Springer. And this book is now part of the master's curriculum here in Ireland in MTU. And I have another book, edited book, that is on blockchain enabled fog and edge computing. Now, if you are interested further, there are numerous works, for example, by Sijam and by other researchers, Adam Wallace and other researchers. They are precisely focusing how we can apply blockchain to spectrum management or spectrum trading, and how to perform a spectrum auction through blockchain. So that is all for today. Thank you very much for listening. If you have any question, most welcome.
Thank you so much, Dr. Mubashir, for your nice presentation. So if anyone has any questions, so please you can write in the chat box, or you can on your mic and you can ask. Meanwhile, we have our assistant dean with us, Dr. Manaf Zaghabi. So Dr. Manaf, if you want to say some words or something.
Can you hear me?
Yes, sir, we can hear you.
Okay, thank you, Dr. Najim. Thank you, Dr. Mubashir, for this informative presentation. It's very well designed and just right to the point, taking into consideration that basically it's dedicated to students. So it's really, really nice presentation. And also, thank you for laying out the areas of future research or potential research in a blockchain. I have a question. It's outside the scope of communication system, because I noticed one of the participants asked a question about the prices of some of the cryptocurrencies, and I noticed the first slide you had, it showed some prices of Bitcoin and Ethereum, etc., etc. So just like to get your perspective on this point regarding cryptocurrencies. So this is different from blockchain, although it's stemming from blockchain. do you think or do you feel that this is like another bubble, like same as they talk a lot about this like tulip bubble that happened in the 1600s? So do you feel the same thing about this, that the cryptocurrencies and the craze that's accompanying them, the prices, and how people got into this? Some people invested very few amount of money, and within like a couple of years they became not millionaires, but maybe even to the limit of billionaires. So do you think that cryptocurrencies are bubbles
So,
also? I hope my voice was.
yeah. So thank you very much for your kind words and for asking this question. Basically, if I quantify the applications of blockchain, blockchain is the underlying technology of cryptocurrency. I can safely say that cryptocurrencies are just 5% or 10%. There are other 90% other applications of blockchain systems in other domains as well. For example, IBM is completely working on blockchain, and Google, and there are other companies and organizations who are, and even the government and even EU has their dedicated initiatives to implement and consider blockchain for different systems. Now, coming back to your question, I don't think so that it can be considered as a bubble. Even if we assume that cryptocurrencies will be completely vanished, although it may be seems difficult because of the capital investment and the interest of the people who hugely invested on this cryptocurrencies. Still, blockchain will be there, and there are numerous other applications where we can use blockchain. I hope I answered your question.
Yes, you did. Thank you so much. Thank you again for this presentation.
My
Back
pleasure.
to Dr. Najm.
You are muted, Dr. Najm.
Thank you so much, Dr. Manaf. So there is a question from the audience that how authentication is addressed in blockchain system.
Yes. So basically, let me give you an example of IoT devices. Okay. So there can be several IoT devices, and you can assume that there can be millions of IoT devices. Now, let's say if we are considering a system where multiple IoT devices are connecting to the server, and the server need to authenticate. So how authentication can be done in that perspective? So basically, these IoT devices, when they register themselves to the server may typically check, perform AAA procedure and then authenticate. But in the presence of blockchain system, the server don't need to perform this AAA procedure. The other IoT devices or the blockchain nodes, which are the part of the blockchain system, they can help, they can testify to the mining process that this new IoT device that is entering or trying to authenticate in the system is a legitimate IoT device, and we can enable it to become the part of the blockchain network. So it's basically the consensus algorithm that will help us to authenticate the other IoT devices. And in consensus algorithms, although there are some attacks like 51% attack, where if you compromise more than 51% of the nodes, then the system can be considered as compromised, but it is difficult to achieve. So this is how one can achieve authentication through blockchain system.
Yes, there's another question. Is there any way using blockchain we can perform bankless cross-border trading? I mean, yes, to say without opening LC in banks.
Yes, there are numerous banks which are working on this project along with IBM, I think. So the goal is to remove the intermediary, okay, which is the bank or the credit card companies. But the problem is that they banks and governments and credit card companies, they have huge investment. How they can enable this technology? So when this technology, blockchain technology came, they receive lot of resistance from governments, from banking sector, because the blockchain technology is directly asking them to remove their role and adopt them. So then with lot of resistance, now the banking sector and government, they are adopting blockchain as a second solution. So yes, of course it can be possible. Broad cross-border payments and LCs and all these things can be possible, but again the systems are not that much mature. For example, I was looking at one of the project where one can trade the energy without involving the centralized authority, but still a lot of work is required, technical issues. For example, one technical issue is the transaction speed. The transaction speed, it is not that much higher in the current blockchain system. When we use let's say when we perform some shopping or transaction on Amazon or any other online place, millions of transactions are happening through debit card and credit card. But if we just replace that system through blockchain, we don't have that much transaction speed because of the underlying consensus algorithm. So researchers are trying to improve, but still it's there's a long way to go.
Okay, as you mentioned that due to the consensus algorithm there is a delay, so can it will affect the performance of delay sensitive networks?
Yes, definitely we cannot simply adopt blockchain for delay sensitive networks because of this transaction. For example, for a typical blockchain network, a transaction need to be validated after 10 minutes. Even if you go and check live how much time the Bitcoin network is taking, Ethereum network is taking, all this information is available on their websites, and you can live monitor that even 5 minutes or 10 minutes are taking to validate a transaction. So still, it is not feasible right now. Maybe in future, in some years, when researchers come up with some solutions, but right now there is still need to work.
Okay, so there are two more questions. How is the blockchain distributed ledger different from a traditional ledger? This is one question. And second question is, using artificial intelligence, is it possible that we can trace block data using hash code?
Okay, so from the first question, so the normal ledgers, basically, as I mentioned in the slide, previous ledgers were maintained using manual records. Then we have the advent of computer, and we were managing those ledgers using database systems or spreadsheets or different word applications. So the basic difference is that, which I also mentioned in the vital characteristics of blockchain, and when I was comparing blockchain with database system. So those are all those basic differences that differentiate blockchain from the traditional ledger system. So I'm not repeating the same things. One can look back at my recording of this session. You will get the answer. And for the second question, can you repeat the second question?
Using artificial intelligence, is it possible we can trace block data using hash code?
You may have heard about quantum computing. So even the hashing algorithm itself, they are in a danger zone because of the more powerful computing paradigm that is coming. Similarly, about artificial intelligence, personally I don't know, but I need to look at whether it is possible or not. I don't know the answer for that question.
I think there are no more questions. One more question is there. Is invalid blockchain, can we change data? No,
we cannot change data. For example, if I make a transaction in a blockchain of 2 bitcoins, and that transaction is stored in a blockchain system. Now, if I want to revert that transaction, I can make another transaction, but the previous transaction cannot be changed. That's why the blockchain system is immutable, non-reputable. We cannot change the previous record. Although we can make another transaction to revert back, but once the data is stored in a blockchain system, that cannot be changed. That is the feature of the blockchain system.
One more question. Can we create our own hashing algorithm that we can use to generate hash in blockchain?
There is one organization, Institute NIST in US. They basically developed and designed a lot of hashing algorithms. So if each year they have annual prize competition around the globe, that if you are coming up with a new hashing algorithm, you are most welcome. It's very challenging to design a new hashing algorithm, but if you are able to do that, you may receive a worldwide recognition from the scientific community, because it's not easy to propose a new hashing algorithm.
As you mentioned that we couldn't change the data. So if someone sent multiple conflicting transactions, then
yes. So there is a procedure for handling such situation, and we call it double spending problem. So this double spending problem occurs because of the consensus algorithm, because of the delay. When you make a transaction through credit card or debit card, there is a central entity that just validate your credit and make the transaction, and the amount is deducted from the database system. Now, when you look at the blockchain system, when I make a transaction, I buy something, okay, that transaction is not validated and the record is not updated. So I can reuse the same amount for another transaction, and this problem is known as double spending problem. And there are solutions for this double spending problem available already in the literature.
So someone asked that, Shafqat Ali asked, in which data structure we are storing blockchain data at implementation phase?
So it's linked list, simply linked list. You can just type on Google, just visit GitHub. You can find a lot of available codes, sample codes, which you can download. Even you can download the whole code of Bitcoin and Ethereum. It's openly available, and you can even change the underlying data structure. You can use a DAG, you can use any other data structure. All those data structures and all the complete codes are available online on GitHub for all the blockchains.
Cryptocurrency investment is safe or not? I think this is the last question. Yeah.
Okay, so basically, I'm not a cryptocurrency expert, so I will not recommend you for that, and I never buy any cryptocurrency. So I'm sorry for that.
Okay, thank you so much for your wonderful presentation and nice answers. So once again, on the behalf of IEEE student branch at the Cork University and students at the Cork University in Electrical and Computer Engineering Department, and our faculty at Electrical and Computer Engineering Department, we are really thankful for your time, for your presentation. It was really nice presentation, and you have given the answers very well.
Thank you so much for inviting me